Okay, so idea number 2, Gibbs free energy, it's a state function. State function meaning that it only depends on the initial and final conditions, not on the process. And so there's 3 ways we can find delta G. This is the first way, which is new to us. So delta G is equal to the enthalpy minus the temperature times entropy. The second way is products minus reactants. That one's the same as what we have been doing. And then the third way is Hess's law. And Hess's law is the same as what we have been doing for enthalpy and for entropy. So for example 3, it says consider the following equation, right? The following chemical reaction. We've done this one before. For A, we're going to use the first one right there. So delta G minus delta H, or equals delta H minus T times delta S. So we're trying to calculate delta G. We have delta H given to us, and we have delta S given to us. And it says that it's at 25 degrees Celsius. Pay attention really quick that this is in Kelvin, so we need to convert Celsius to Kelvin. So the temperature is 25 degrees Celsius. We add 273 to it. It becomes 298 Kelvin, right? The other way, if they don't give you the temperature, this little standard state right there means that you should automatically know it's at 25 degrees Celsius or 298 Kelvin. So if they don't give you that temperature, you should just know it based on that little symbol right there. Standard state, standard temperature, standard pressure, standard molarity. It says calculate the value of delta G. So we're calculating delta G. We have delta H minus T times delta S. So our delta H given to us is right there. So I'm going to plug that in. Negative 198 kilojoules per mole. We're subtracting it from our temperature, which is in Kelvin, so 298 Kelvin. And then our entropy, make sure you put it into kilojoules, because if you look, we have joules here, we have kilojoules here. We cannot add them or subtract them unless they're in the same unit. So I'm going to convert entropy into kilojoules. That's usually how I do it. You can easily convert enthalpy into joules though. So negative 187 joules per mole Kelvin. And I'm going to divide that by 1,000 because that's our conversion factor. Another way I can write it, I'll write it a little bit more proper. We can multiply it by the inverse, right? So we have 1 kilojoule is equal to 1,000 joules, because kilo is 1,000. So we're dividing it by 1,000 essentially. So joules cancels out and we're left with kilojoules at the top. Okay, so go ahead and multiply all of that out and subtract all of that out. And you should end up with negative 142 kilojoules per mole. Write a question if you have a question, but make sure that your math matches this. Make sure whatever you're getting confused on, you go back and sort through it. All right, for B, we're going to do products minus reactants, so that this is the same as it's always been. So we have to calculate delta G, Gibbs free energy, given the following GF. So whenever you see GF or HF or SF, you're doing products minus reactants. So that formation, that little f, is products minus reactants. We have our products going first, and we have one product. It's the 2 SO3s. So we have 2 moles of SO3. And SO3 is, for Gibbs free energy, is negative 371. Minus our reactants, and we have 2 reactants. We have 2 SO2s and then 1 oxygen. So 2 SO2 is negative 300. Plus, we have 1 oxygen, and it says right here that delta GF is 0 for elements at standard state. So oxygen is diatomic. That's what it is at standard state and standard temperature, standard pressure, right? That's what it is off the periodic table. So that's just going to be 0 for oxygen. Right, so multiply all that together, subtract them, and you should end up with negative 142 kilojoules per mole. And that's awesome because that matches both of them, right? They should be the same. No matter which type of thing that you use, it should be the same. The only one that can slightly vary is the bond enthalpy one. Because that's just not as accurate. But no matter what other process, they should be the same. Alrighty. Scrolling down to C, it says calculate the value of delta G given the following reactions. This one is Hess's law. So you're flipping, you're multiplying, you're dividing the reactions in order to get the correct equation. And so our equation overall that we need is still 2SO2 plus 1 oxygen, and it makes 2SO3. I want you to pause it. It's the same equations as the first lesson. I want you to try to do it yourself, though. So don't look at the first lesson. Don't look at what I'm about to write, but try to get Hess's law, flipping and multiplying and dividing to get the overall equation. All right, so first I notice there's 2 SO2s on the right. I need 2 SO2s on the left, though, so I'm going to flip that one. So I'm flipping it, so I have 2 SO2 plus 2 H2O, and it yields 2 H2S plus 3 oxygens. All right, next thing I notice is that SO3 is in the second one, and I need SO3 on the right-hand side, but it's on the left, so I need to flip it. There's only one of them. I also need to multiply it by 2. So I flipped the first one. I need to flip the second one, and I'm going to multiply it by 2. So I end up with 2 H2SO4, 2 waters, and 2 SO3s. All right, the last one, I noticed that there's 2 oxygens right there. I need 1 oxygen, but I also had 3 oxygens from the top, right? There's two equations that have oxygen, right? There's the oxygen right there. And so I need to make 1 oxygen overall. If I just keep it as H2S plus 2 oxygens and H2SO4, if I look at the left and the right, that would give me 1 oxygen on the right. I want that 1 oxygen on the left, though, so I'm going to multiply this bottom equation by 2. I'm going to have 2 H2S's. I'm going to have 4 oxygens and then 2 H2SO4s. All right, now I'm going to look at what's the same on the left and the right-hand side and cross those out. We have 2 waters and 2 waters. We have 2 H2S's on both sides. We have 2 H2SO4s on both sides. And then we have 3 oxygens on both sides, which this can be reduced down to 1 oxygen. So overall, we have 2 SO2 plus 1 oxygen, and it makes 2 SO3s. And then the last part is just doing the same thing to the numbers. And so we flipped the sign for the first delta G, so we made it positive 1006. We flipped and multiplied the second delta G, so that's going to be positive 164. And we only multiplied the third one, so negative 1312. Add all of those together and you should end up with negative 142 kilojoules per mole. And that makes sense because that's what the answer was for A and for B. So for Gibbs free energy, you need to get the same answer for any 3 methods, depending on what they give you. The only one that is different was for enthalpy, and that was for bond energy. That will give you a slightly different answer. But for entropy, they'll all be the same. For Gibbs free energy,